Hey everybody, and here we are in lesson 11 in the Foundations of Algebra course. Let's get right to work. We spent the past few lessons really nailing down the operations, and at this point we've got both addition and multiplication squarely under our belts. In today's lesson, we'll apply these operations to different situations. So let's get, excuse me, right now, I'm being told it's important. Guys, we now take you to the Math Corps News Network studios for this breaking report.
Good evening. Rocky Stones here with a special report. At New York's Kennedy Airport today, an individual later discovered to be a public school teacher was arrested trying to board a flight while in possession of a ruler, a protractor, a set square, and a calculator. He is being charged with carrying weapons of math instruction.
Okay, in terms of real-life applications, you might be thinking to yourself, well, haven't we talked about applying each of the operations? And you're exactly right. For instance, when we talked about division, we introduced applications that involve division, and you worked on that homework, and at the end there were story problems where you had to apply using division. Well, it turns out it's not only important to know how to use the operations in these applications, it's important that you're able to recognize when to use the correct operation. So what we'll do today is we'll mix them all up. So you'll have to spend most of your effort recognizing which operation we need to use. All right, so let's get right to it. Here's a few story problems, just randomized here. All right, first one. Each protein shake contains 12.5 grams of protein. How many total grams are there in 5 shakes? All right, we'll take a look at that. And now remember, we're just thinking about which operation should we be using. What jumps out at you? Yeah, you. No, behind you. No, the other behind you. Yes, good. Multiplication. We've got 12.5 5 times, right? This is like one of the most common applications of multiplication. Good. So let's do our multiplication. So we need to take 12.5 and we need to multiply it by 5. Now, this is the how to apply with piece of cake, right? We know how to do this multiplication. So 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 1 is 5, plus 1 is 6. We've got 1 decimal place in our factors, so our answer should also have 1 decimal place. So 62.5. So there are 62.5 total grams. There's our answer. Looking good? Excellent. Here's another one. A baby weighed 7.5 pounds at birth. She gains 2 3/4 pounds. How much does she weigh now? All right. What's jumping out at you? Which operation? Let her rip. Just scream them out. Nice. Good. Gain. Okay. We're adding on 2 3/4 pounds. So we're gonna use addition here. Very nice. So we know what to do. 7.5 plus 2 3/4 pounds. There it is. Now, we know we don't mess with mixed numbers, so if we convert them into fractions, there we go. They've got to be the same things before we add them, so convert them to fractions with a CD. Now we add them. And this isn't a rule, but when our numbers come to us in mixed numbers, it's often nice to give it back in our answer as a mixed number. The 41/4 is a perfectly good answer, but that's the same as 10 1/4. So we can quickly convert that into a mixed number, and there's our answer. So how much does the baby weigh now? The baby weighs 10 1/4 pounds now. We're good. Nice job. Here's another one. Suppose you're watching Jeopardy and 2 contestants have scores of 400 and -200 respectively. We want to know what the difference is in their scores. What is the difference in their scores? Now here the language is really explicit, isn't it? Difference. So we know we're going to subtract. Well, let's do it. So we've got 400 minus -200. And you know the deal. Subtraction is addition of the opposite. So I'm going to add the opposite of negative 200. And I end up getting 600. So the difference is 600. And I think on Jeopardy, the scores are in dollars. So $600. All right. Very nice. One more. So a painter wants to pour 3/5 gallons of paint into 6 containers, with each container getting the same amount. How many gallons should he pour into each container? All right, so he wants to take this 3/5 gallons and he wants to split it up into 6 equal parts. That sure sounds a lot like division to me, and I hope you were thinking the same. So let's do that. Let's take 3/5 and divide it by 6. All right, 3/5 divided by 6 is the same as 3/5 times 1/6. 6 is reciprocal. We multiply straight across, simplify, and there's our answer. So each should get 1/10 of a gallon. He should pour in 1/10 of a gallon into each of the containers. Nice work. Now, sometimes these applications, we'll kick it up a notch. Sometimes these applications involve multiple operations, all right? And that's fine, we're good. We're good with each of them individually. Now we can package them up. Here's an example. Say a person drives at a rate of 23 miles per hour for 2 hours, and then at 40 miles per hour for another 5 hours. What is the total distance traveled during those 7 hours? All right, well, if you think about it, the total distance, it seems like it's broken up into these 2 parts, right? These 2 legs of the trip. One where the person was going 23 miles per hour, and then another one where the person was going 40 miles per hour. All right, well, that just means that the total distance is the first distance, the first part, plus the second distance. And we can figure out each of those parts individually. All right, so the first distance well, what we need to do is take the rate and multiply it by the time. So 23 miles per hour for 2 hours, well, that's 46 miles, isn't it? And then the second part, same thing, the second distance. That's just the rate, so 40 miles per hour times 5 hours. And that's just 200 miles. And now we can come up to our green expression there. The total distance is the first distance plus the second distance. But guys, that's just 246. So the total distance is 246 miles. There we go. All right, here's one more. Let's say the low temperatures over a 4-day period were 3 degrees on the first day, -8 degrees on the second, chilly, 0 degrees on the third day, and -7 degrees on the fourth day. What we're being asked is, what was the average low temperature over the 4-day period? Well, I'm sure you guys remember that to compute an average, you add up all the numbers, in this case temperature, so the sum of all 4 temperatures divided by the number of temperature readings. All right, so 4. So to figure out the average low temperature, we really need to find the sum of the low temperature. So we need to add up those 4 temperatures. Well, we can do that. It's just 3 plus -8 plus 0 plus -7. And if we just go through this sum left to right, 3 plus -8, you can see those N's and P's in your head, but by this point it's -5 plus 0, still -5, plus -7. -5 plus -7 is -12. And there we go. So to get the average low temperature, we need to take -12 and divide it by 4. And a negative divided by a positive is going to be negative, and in this case, -3. Here's our answer. The average low temperature was -3 degrees. All right, guys, I think we'll call it a day because, like most things, you're probably going to learn this much more deeply by working through problems on your own or with your colleagues. So I'll let you get right to work. Have a great day, and I'll see you in our next lesson.